Hello, welcome to this presentation about towards socially intelligent agents with mental state transition and the human value. Building a socially intelligent agents involve many challenges, one of which is to track the agent's mental state transition and teach the agent to make decisions guided by human values. In this paper, we propose to incorporate mental state simulation and value modeling into dialogue agents. We use explicit graphical representations and a hybrid parser to track agents' mental state transition. We also learn a value ranking model based on the knowledge base ValueNet. Empirical results show that the proposed model attains SOTA performance on the 3 prediction tasks in the text-based game dataset Light. Light is a large-scale fantasy text adventure platform for studying grounded dialogues. This figure shows a typical local environment setting, including location descriptions, objects, and affordances, characters, and their personas. Agents can talk to other agents in free-form text or take actions defined by templates and express certain emotions. Given the environmental setting and observation history, our task is to predict the agent's utterance, action, or prediction for the next turn. To achieve this goal in a socially intelligent manner, we model the agent's mental state transition. The mind model is proposed to depict the agent's belief about the underlying state of the text word. A graphical representation of the mental state is proposed as illustrated in Figure 3. Nodes in the graph represent the involved agents and persona descriptions, objects, their affordances, and setting descriptions, which will change as the game setting switches. The relational edges between these nodes describe the state of mind, and the mental state is updated with observed dialogue history or actions. The theory of basic human values developed by Schwartz tries to measure universal values that are recognized throughout major cultures. A set of 10 basic values are identified and serve as the guiding principles in the life of a person or group, as shown in Figure 4. We denote the available alternatives to be a set of exhaustive or exclusive utterances or actions. The value function FE describes the utility score of the alternative from the value dimension V. For example, if AI is more preferred than AJ in terms of security, then F security AI should be larger than F security AJ. In Light, the agent's value priority is reflected by its persona description, using the same value function to approximate a value priority parser, FVP. Here, P is persona description. The utility of candidate AI to person P is Euclidean distance between its value priority and the candidate's utility score. The overall architecture of our proposed framework is illustrated in Figure 5. To begin with, a mental state parser will parse setting descriptions into graph representations and initialize the agent's mental state. Besides the mental state updating, the parser also outputs an action mask that rules out actions that are physically or causally impossible to take. A graph encoder and a text encoder will convert the mental state graph GT and the dialogue observation OT into vector representations. The same text encoder will be used to encode the candidate CT. In step 7, the context vectors are combined by a bidirectional attention aggregator, and each candidate is assigned a score with the MLP. The action mask is then applied to get the feasible candidates under current mental state constraints. In step 10 and 11, the top 3 candidates from the last step will be fed into the value model and re-ranked. We propose a hybrid parser to process dense and sparse information efficiently for actions that are template defined. We define delta GT as a sequence of update operations of the above 2 atomic types. And for utterances which have a continuous effect of the word state, we use a recurrent model-based approach. And then for graph encoder, we use relational graph convolutional network. We use a BERT CLS token representation for text encoding. And the value model is a BERT-based ranker trained on knowledge-based ValueNet. A custom input format is constructed and fed into the BERT encoder, and the utility is output from a regression head on top of BERT. And here are the results. In the action prediction task, the discrete parser outperforms the purely continuous method and the BERT-based baselines, while the continuous mental state parser misses the hard constraints introduced by less frequent actions. It updates the graph implicitly with dialogues and shows a better performance than the discrete one on dialogue prediction and the emotion prediction. The hybrid mental state parser performs the best among the 3. And the proposed value model teaches the agent to make decisions that are aligned with assigned role and further improves the overall performance in all 3 tasks. And if you are interested in this paper or what we are doing, feel free to send me an email. Thank you.